Hi, and welcome to the podcast. We've got a really special guest, someone I know really well. We worked together at Cloudera. We had a lot of fun on some really cool streaming stuff. It's John Kuchmek. He's a principal solutions engineer at Cloudera. And we've done meetups together. So you've probably seen us around, usually covering things in streaming like Apache NiFi, Apache Spark, Apache Flink, Apache Kafka, other things. We did a meetup a little while ago where we covered Pulsar and NiFi together for NFTs and solving the are NFTs fake and is it a scam thing? And with the help of Kudu, maybe we did.
Yeah.
So I think we'll have a cool discussion today, and we're going to cover some things we haven't covered in previous ones. Basically, the very powerful streaming ecosystem that Pulsar fits into the middle of, and we've got official connectors with Cloudera. So when we talk about this, these are things that have been tested by people out there. It's not just someone threw up a connector somewhere. It's been tested by serious people. So it's not just my friend David wrote something and put it out there and it works. It's out there for real. So the longest intro ever, and I barely talked about his background.
Well, let
Hey,
John
John.
introduce himself. Like John, tell us about yourself.
Sure. So yeah, I mean, I've known Tim for God, going on like 7, 8 years, something like that. It's been a long time. So I actually used to be a customer. So Tim was my solutions engineer when I worked at a company called American Water, and so there I kind of really delved into a lot of the streaming ecosystem, being able to pull data out of operational technology, so SCADA systems, real-time data feeds off of PLCs, things like that. We also built a lot of cool mechanisms to do, incremental batch, not true change data capture, but out of SAP HANA before anyone had CDC for SAP HANA really. I've kind of been able to get my feet wet in a lot of different streaming technologies, and now I'm on the other side of the fence where I get to help customers with their streaming problems. And so Tim and I have, I don't know, God, we've done how many? I mean, probably 30 so meetups together, I'd say over time, probably more than that.
Felt like that.
Any chance? Yeah, we only live like 45 minutes from each other too, so we're not that far. So, but yeah, so it's a little bit of my background. But before that, I was actually a manufacturing engineer, so I worked at a helicopter plant. Before that, I was a research physicist. So I've got like a pretty diverse background, which I think is beneficial for being able to figure out how to help businesses implement streaming technologies and use cases. So,
So when you talk about that American Water, you said, right?
yeah.
So was that like were you monitoring like water supply or flow through systems or what?
So the biggest thing that we worked on was we were actually pulling the sensor data off of the raw water intake facility, and we it's actually, there's an article about this. It's pretty cool. We kind of built a test lab to start to dope the water like off to the side, obviously not going it to the actual water treatment facility, but we'd pull some water off and we'd set up the same system with the sensors and dope the water and actually try to figure out like certain signatures based on the sensors being matched. Like, could we match the chemical to figure out what was coming in? Because sensors aren't looking for specific chemicals. They're looking at turbidity. So like, how much, there's particulates within the water. That's looking at, how much oxidation there is, right? So like there's the temperature sensors. So all of these different things. So as you look to map, the different sensors together, we could try to figure out like, could we detect something before it even reached the water treatment center? And if it was detrimental, could we then stop it, right? So that way we're not necessarily poisoning the well. So we did that. We did a POC where we put Apache NiFi um, on iPads. So you essentially could have the field workers that we'd be able to track, like, all right, we'll match that with traffic patterns to figure out like if something's going wrong, could we reroute them, or if there's bad weather coming, also to monitor for safety. So there was a lot of things, like we were very safety driven and very health driven with the water. So there was a lot of cool use cases that we utilize streaming for.
Now, I've okay. So I know we've talked about this a few times, and Tim, you brought this up in the intro. So there are a lot of different Apache tool sets that are part of this tool chain. What is NiFi?
So Apache NiFi was a tool that was out of the NSA. So I think it went open source in 2012, if I remember correctly. It actually stands for Niagara files. So that's why it's capital N, lowercase I, capital F, lowercase I. The NiFi is a GUI-based data flow tool. So it makes it very easy. It's either low code, no code, depending on how you build your process, to build a data flow. And it has a bunch of built-in connectors. I think there's like 328 or 330 roughly built-in connectors that they call processors. So each processor kind of behaves like a function. Like from a code perspective, you can think of it as like it does like something as a function would do within code, and then stitching all of the functions together, your workflow kind of becomes like a jar or a series of classes, and then that goes into processor groups and so on and so forth. So it makes it anyone with an engineering mindset, and I tell this story. Was it 2 years ago now? Yeah. So, or maybe it was last year. I forget what it was. So I think it was 2 years. Right when the pandemic started, the International Day of the Girl. My daughter is, at the time she was 13, so it was a year ago. She was 13. We actually had her, like, we installed NiFi on a Raspberry Pi, and we were pulling data out of a temperature sensor, and we were doing some changes to it, like converting it, because everything would come in Celsius, so we would then convert it to Fahrenheit. But she was able to do all of that in NiFi, and like although she does have the ability to code a little bit, I wouldn't say she's like an avid coder. But she does have a good engineering mindset. So I even say, like, it's possible for a 13-year-old to build a flow. And so that way you really are kind of giving anyone with the capability that has an engineering mindset to be able to build a pipeline and start to get data into, say, a database or whatever, and be able to do the inspection that they need.
Okay. Yeah. And I know, like, you and Tim both have like worked on, the combination of multiple tools. Tim, like being the Pulsar expert here, like how does Pulsar and NiFi work together?
Well, it's kind of the dream team. I mean, I like that combination so much. I mean, I have like 1,000 pounds of stickers here for what I call the flippin' stack. Because to me, Pulsar does a good part in the middle, but NiFi is that tool. Like, how do I get stuff off of like these crazy little glasses? How do I get it off a water pipe? How do I get it out of some old system, some logs, big data? Like, there's so many syncs, and it's so rich and so easy to do this without having to write 1,000 lines of code. NiFi is my ingest point, and often a sync. Pulsar in the middle. I put some functions in there to enrich and transform, and then Flink after that, or somewhere on the pipe. It's nice with Pulsar if I want 20 people to concurrently run it and do their own processing, I can. And then Flink and Flink SQL do, joining streams, joining the cross on the streams, getting all that data together. I mean, that's awesome. I mean, that was my talk at ApacheCon, was citizen streaming engineer. How do you make it easy for people to write what used to be, writing a real-time streaming app is something you're paying, high-end consultants some big money. But if I give you NiFi, Pulsar, and Flink SQL, all you got to know is drag and drop, a little YAML maybe to configure Pulsar maybe. If you use the cloud, you just press a couple buttons. NiFi can create those topics on the fly the first time it publishes data in. And then on the other side, you write some SQL to join things. You've built a real-time, scalable streaming app with, like I said, as long as you have an engineering mindset, you don't need the super coding. That's why I said citizen streaming engineer, like they say citizen data scientist. I don't need, 10 years of programming, Java, Scala background. I think when we have time at KubeCon, maybe I'll show Matt how to build a flippin' app. Maybe we'll do that real time. I mean, if you've done SQL and you can use Facebook, you could probably build an app. It's not the only part that gets tricky is sometimes people give you the worst data they could find. Like I got some real time transit data, and it's some nasty RSS, and there's things I really need to pull apart. So there's some extra steps you could do in some code or in NiFi, but the steps may be, you might have to look at the manual, go, oh, I could do that or that, or look at an article that John or me or Pierre or people have put out there and go, okay, let me bring that in. NiFi is very modular, so I could easily pull in a processor group that does something. Very easy to patch together an app Lego style.
Okay. So if I can paraphrase what both of you have said is NiFi is almost the user interface that, gives you the nice GUI. Pulsar is the kind of the highway to move stuff around behind the scenes, and then Flink is your reporting engine. Lack of a better word.
Yeah, I mean, I would say, yeah, for the most part, right? When you think of the pub sub with Pulsar, it's not just, moving it around, but it also gives like the capability to store the data for a temporary period of time, right? So NiFi is not meant to maintain the data, although it does persist at the disk to make it resilient. It's not meant to hold on to the data as soon as the flow completes, that's it, it's gone, right? The data does not meant to stay there. Whereas Pulsar, you might have people, when they're consuming applications, be able to be consuming them at the rate that they want. So you might have someone say, I need it now. You might have someone say, I need it once a day. And so you can maintain that data in a pub sub model to be able to pull it at the rate that you want. And Flink SQL, I mean, it's not just reporting and analytics, but it does some really cool stuff with, essentially you could do a lot of windows. So it's very important for where I came from, being able to window data sets, because it's one thing to understand what's happening at a point in time, but it's another thing to understand what's happening aggregates over a time window. So every minute, every 5 minutes, every 10 minutes, do I see the aggregations are going up or remaining consistent? Because you'll have like sensor read fluctuations could actually go back and forth, and you'll kind of have like a maximum minimum. But the aggregation, the total aggregation should never reach past a certain threshold over a certain amount of time. So, just another thing. So a little bit more than just, the SQL aspect, but, Flink is a pretty robust, tool to be able to read that data in real time.
And Tim has decided to bring his cats on screen.
They have decided to enter the facility. I think they thought something we were saying was stinking. I don't know. No, yes. This guy's a new guy. He explores. What are you gonna do?
So John, you mentioned some of the apps here are really IoT sensor based, but what about like more kind of modern web apps? How have you seen some of maybe like the stack used in more web type or end user type applications?
So, I mean, you can build a lot of end user applications. There is actually, we have a flavor of Flink SQL that we call SQL Stream Builder that allows you to go ahead and create a materialized view off of the data set. And so you can feed a application in real time, the data feeds. So you could actually have like a point in time of what things look like. Dashboarding is definitely an important thing. Now, pulling data off of web apps is definitely possible as well. Like you can, if there's rich APIs to be able to pull data from, like NiFi is not just about sensors to pull data. NiFi, like I said, has a rich set of connectors. So you can have both a push or a pull model, depending on what you want. So you can actually have NiFi be a listener. So if you wanted to do something within an application and push the data to, say, a website, you can use NiFi as that endpoint. It go ahead and grabs the data set, and then you could do some transformation on it before you push it up into Pulsar, and then potentially, read it from Pulsar for Flink, and then create that materialized view to dashboard exactly the thing that you've been pushing.
Okay. The cat has made an appearance again. What's the cat's name, Tim?
This one, his unofficial name is Sploot. His real name is Ash.
Ash. Okay.
Yeah, he's very friendly. You're very friendly, right? Yeah.
Yeah.
I think he could write one of these apps. He's like,
oh boy. So I guess that's Tim's challenge to get that app under.
If I can get a cat to write an app. Oh, that's not a bad talk title for a conference.
That would be good. Yeah.
Tim can teach a cat to build an app with Flip and Stack.
Well, you just need to get the sensors around the cat's neck and the collar, and then have it wander around so you can track your cat while you're at a conference.
Someone did
Cat
that
tracking.
with
Put
a
a little
video
camera on
feed.
his head.
Yeah, someone did that with a video feed. I think it was a dog where they actually followed the dog around on video, but we
Nice.
could potentially bring that in real time and then you do one of your, your TensorFlow processor in NiFi where you're actually the recognizing exactly what the image is, as it comes in, essentially doing character recognition or doing, object recognition. Be pretty neat, real time that.
Yeah, not a
Yeah.
bad idea. I could hook that up to the. I got a NVIDIA
Yeah.
pretty powerful guy over there that would run that real time. Maybe with PyTorch. We'll see.
So we as we're talking about monitoring our cats. I don't have a cat. My daughter does, so I guess I can monitor my daughter's cat, but I don't really care. So, what other weird use cases have you seen Pulsar and NiFi and the whole stack be used for? Like, are there some other eclectic use cases that you're like, yeah, this is a really weird one, but it kind of makes sense?
I'll let you go first, Tim. I'm trying to think of. So I don't think anything's weird. Like, I mean,
Well, I've got some
Okay.
weird ones.
You can say cool. You can say cool.
fair enough. Go ahead and give me a cool one first, Tim, and then.
Well, when we were running the meetups, I used NiFi to find and download live music streams. That's kind of weird. I mean, because NiFi could be a general connection of anything. I mean, the NFT thing we do is a little weird. Doing real time weather, pulling all the weather in from the country.
Okay. Wait. So when you say the NFT thing we do is kind of weird, what is the NFT thing you do? Like, you can't just it's just this weird thing. Like, you have to explain what the weirdness is.
So Tim and I did this meetup. It's actually you can go to YouTube, I'm pretty sure. So I don't know if this podcast has the capability to give links somewhere, but I'm pretty sure we can get you that link. We went in just to look at NFTs. Now, I kind of come from a background where I think NFTs are kind of BS a little bit, so I'm biased. But Tim was actually able to pull in NFT data into Pulsar. Store it, and then NiFi was actually taking that data in real time and streaming it. Now, I did some transformations of the data set because it came in via an API, so it was JSON. I flattened the JSON out to give me a nice row columnar type format, but it also included the links to the GIF images. And so we have internally a tool called data visualization, which is really nice. It's a great dashboarding app. And so I ended up creating a table. So it would stream into Kudu, Apache Kudu, so other open source tool, with Apache Impala on top of it, which, Kudu is the storage layer, Impala is the SQL layer. And so now I have a good table, and I use the data visualization application to show all of the different NFTs, and it actually showed the GIF image of the NFT, plus who bought the NFT, who sold the NFT, what the price was for. And the thing that we found out was that the same person was buying and selling the NFT. It was the same user, which means that they are artificially driving up demand. At least that's what it looked like. I said, obviously, we need to do additional inspection, but it doesn't seem like there's a ton of regulations around the buying and selling of NFTs like there is for stock. So that's something that they call pump and dump in the stock world. They artificially drive up demand for the stock, and then they dump it all, and then they make a ton of money. So it looks like that's what was happening with the NFTs, which is why why in the beginning we said, NFTs might not be, as big of a driver as people think. So.
That's interesting. I think you get a lot of that, in the new kind of digital currency side as well, whether it's NFTs or even crypto.
Yeah.
There's a lot of crypto out there that's questionable.
Well, look at what is it? Kardashian had to pay, I forget how many millions. Was it $1 or $2 million because of what she was posting on Twitter? So, I mean,
it's a weird space now, right?
It is. Yeah.
But those are use cases that you two came up with. From a customer perspective, or out there in the real world, like actually running today, are there anything that stands out as like a very unusual or interesting use case?
Interesting. I mean, there's a lot of interesting use cases. So being able to marry, weather data, traffic data, and crime data was something that we worked on as well. I thought that was kind of neat, one
So
thing that
do more crimes get committed when the weather's bad and people are stuck in traffic?
no, so more of like everything was around the safety of field service workers.
Mm.
And so as they, as you go through like traffic, having traffic, Google Maps will reroute you to where do you want to go or whatever maps engine that you use. They recognize traffic patterns and they go, hey, we found a better way, so we're going to reroute you. So that's one thing. But taking that and then saying, hey, there's a storm that's coming, and being able to figure out like if the storm is localized to a specific area, obviously this might cause flooding in an area, being able to figure that stuff out and then reroute them yourself was something that we thought about, as well as crime. So if there's actively something going on, like there's, sometimes you'll find out about active shooting events where all of a sudden now there's police on scene, and that's not actually captured in like a real-time traffic app. So now you can say, hey, stay away from there. It's not safe, so reroute them a different way. Or if you were, sending like a worker to an area, like for a house for a service, and all of a sudden there was a crime event that was happening nearby, okay, like we don't want to send you right now. We'll basically reschedule that work order for another day. Or if it
Mm.
was a high crime area, make sure that you match it to be able to send them early in the day rather than later in the day, or being able to map time to crowd. Like there was a lot of cool stuff that I've seen used. I've also seen it used for like pulling data information off of Apple Watches to help with understanding health. I mean, I can't really name the client, but like, there, there's a tool out there called Validic, by the way, that does it helps pull the data off the Apple Watch itself, but it sends what's called an HTTP SSE, so a server sent event. So NiFi can be positioned to go ahead and grab that server sent event stream and then be able to push it into something like Pulsar downstream, so that way you can have people consume it and build applications off of it later on. So I've seen a lot of cool stuff. I mean, I can't say all of it, unfortunately, because some of it is very proprietary, but for the cool stuff that I've seen or it's been talked about in the news or something, those are things that I can kind of discuss.
Okay. So it's interesting. I think that a lot of people that I have talked to consider, when we talk about like this big data type problem as large company problems, but it kind of permeates all sizes, right? So smaller companies, mid-sized companies, everybody can make use of these tools.
No, I agree. I mean, so I've actually worked with some of the largest customers that we have, and I've also worked with some of the smallest customers that we've had. And it's not necessarily the size of the customer. I mean, everyone realizes that data is important now. Making decisions in real time has become even more important. The old days of ETL and batch workloads and having data like be stale 24 hours, that's not going to help. Now, obviously, larger corporations like financial sector, to be able to do fraud detection in real time, that's a good use case that we see. You can actually get the data in a real time feed and then try to do some intelligence on that data set and then go ahead and say, hey, this looks like it's a potential fraud case. I don't know about you guys, but we work with some banks, and I have, my bank has alerted me like, multiple transactions from different places within the same amount of time. Is this you? Call us right away. If not, we're going to turn off your credit card. Right. And then they temporarily shut down my credit card until I give them a call. Now, I think that's great because now I'm not having to worry about money being taken out of my account. I can give them a call back. But then really small companies that we've dealt with that, they're doing, mom and pop type shop stuff to be able to understand like how they're machining data, or how they're machining parts a little bit better. Like, there are smaller companies that produce like maybe just one part and everyone in the world uses that one part kind of deal. And they're not a huge company, right? They're not cranking out millions of different products. They're specialized in one area, but they still need to understand, because if that machine goes down and they can't actually service it soon enough, then what ends up happening is that they ends up losing millions of dollars, which is their bread and butter. So it doesn't matter anymore. I mean, everything is censored, and with networks getting better and better, we're moving to 5G. I mean, IoT is going to take over the world, my opinion.
Okay. No. So as you do work with these folks, and Tim, you can jump in too if you want to answer this, or John, either one. What are the biggest mistakes that you see people make over and over again?
You go
John's
first,
laughing.
Tim. I'm laughing because I've seen a lot of bad mistakes.
I got one. Remember that truck chassis company?
Yes.
I mean, at one point, very small IT group, and Matt, we've talked about them before
Okay.
because of why they shut down their IT. But when they first started, the value they got out of the modern streaming stack is using NiFi to automate things they did by hand. Like reading an email, taking a file out, downloading it. Like that part they did well, but then they took a really antiquated system and tried to move it without improving it and changing it to a modern one. They're like, yeah, these old mainframe queries on our 100 records. I want to do that on this giant set of data or this giant streaming set of live data. I'm going to bring in more streams of data and I want to do it the same old way. I want to do those same old reports and print them out and no one's going to read them. If your mind's not there, the app's not going to be there.
I'd say that's the biggest thing that we see is people coming from legacy systems, moving to modern architectures are not re-architecting. They want everything to be the exact same as it was before, and it can't be, right? There's a reason why it's not, there's a reason why it's antiquated, right? There's a reason why it's legacy. There's a reason why no one supports it anymore. It's because everyone's gotten away from that type of architecture. Beyond that, doing things like you've always done. When everyone says that's how we've always done it, it's my least favorite lines ever to hear anyone say in the world, because I'm like, well, that didn't work for you before, so why would you continue to do it the same way? And then the other thing is that, especially with NiFi, so Mark Payne, who is one of the co-creators of NiFi, and obviously a PMC, he put out a series of videos called Anti-Patterns. So it's 5 videos where he actually goes and he figures out or tells people, like, here are the things that we see in the field that people should never do. So NiFi has evolved a ton over the years. When it first started, everything was about the flow file or the stream. Now they realize that it needs to also have a lot of record capability. So you see like old school methodologies, or like, if you go to Stack Overflow, it's like, well, if you just do this, this, and this will work. And you're like, great, that was true like 6 years ago, but like now that's not the best way to do it. There's a lot that's changed. So like updating and enriching records, there's literally a processor called update record. Whereas before, back in the day, you usually had to then pull it up into an attribute, use the expression language to go ahead and modify the data, then pull it back down. And what people don't realize is, like, in order to do that with a record, you have to split the file. So if it's millions of records, you now have gone from one record to millions. They share the attributes across the line, except for the ones that you want to modify. All of that gets stored in the JVM. So, you essentially get this memory overload that's happening. So there's just so much like bad patterns that occur when people build flows. And it's primarily because they haven't really been up to speed on the net new stuff. So for me, like, watching Mark's videos, like whenever I go to a customer and I see like bad things, I'm like, you need to watch this. Even when I'm just just getting introduced to NiFi, I'm like, before you build anything, please watch these videos. Like, they're very important videos to watch so you don't make mistakes.
That
Yeah.
is critical.
Yeah.
Yeah. Okay, cool. So not only are there mistakes that people make, they just don't understand the technology sometimes.
Yeah.
And that's another area that I see quite often, right? So when you've got someone who is migrating from a legacy system, in the re-architecture, I know it's a big thing. I've seen it myself with other technologies as well. But I think it's also just the knowledge gap. So are there a few features or things that are underutilized or underknown about, like the hidden features, or God, everybody should know this, but they don't? Let me tell everybody what this thing is.
So through the UI perspective, a lot of people don't realize this, but when you click on a processor, when you right-click on a processor, there's a view usage category. That view usage category takes you directly to the documentation of that processor. And I couldn't tell you how many times, like I've worked with a customer and they're like, well, I don't understand what this means, right? So now you highlight over it and it usually does give a description, but it literally having that capability to go right to the doc from that specific processor, not having to Google it. And especially like a guy like, Tim or I have been using NiFi for a very long time. So our cache on our browser might take us back to like, NiFi 1.1. we're on 1.17, about to be 1.18 soon, right?
No,
So
118's out, man.
oh,
I'm running it.
118's out. There you go. See, I'm a little
I'm running
behind
it.
on the time, so I've been traveling, so I apologize.
It's
But
like
yeah,
2 weeks. 2 weeks.
yeah.
Crazy.
Well, I've been on the road like 3 of the last 4. So, but like you look at that, there's been so many changes that have occurred, like, and those processors change a little bit. Like, they're not drastic changes, but there might be net new functionality. Another thing that people don't use a lot is parameters. We are trying to push the utilization of parameters. Back in the day, and this goes back to what used to be done versus now, is variables were the thing. So everyone used variables, but the problem is variables, don't have the same richness that a parameter does. So if you were using a variable before at NiFi, you need to use a parameter. If you have things that you want to port over easy from like one environment to another, use parameters. Because if the parameter set, if you're using parameters, you can move that flow relatively easy and then point to like maybe a file and system or something. And then essentially, you don't have to change every processor where like you have a URL or you have a path, right? If that changes on the new system.
Oh, cool. Yeah. I mean, very useful. They seem like common sense things, but their usability of, features like that, they make a lot of difference in people's lives on a day-to-day basis. Yeah.
Completely agree.
So, Tim, final thoughts from you.
Well, I think it goes down to, when you have someone who's got a lot of experience with it, listen to them. If you have the pleasure of having someone like John Kuchmek in as when you're a potential customer or you're at a meetup or an event, listen to what they're saying, and ask for things like we were talking about today, anti-patterns. Where's the best place to get information? What should I use together, and what should I not? Like, people ask me, should I do everything in Pulsar? No. There's things that go in NiFi. There's things that go in Flink. There's things that go in Spark. If you try to I've got the one thing that does everything, well, a Swiss Army knife works, but if you built a house with it, you're spending a lot of time and you're suffering. Don't, just because it can do it, a brick, I could use a brick to tear down a house, but, there might be some, I might get in trouble.
Makes sense. So, John, thanks for hanging out with us today. We appreciate you sharing some knowledge with us and telling us a little bit about NiFi and some of the other experiences you've had in the background here.
Yeah, cool. Well, thanks for having me, man. This has been fun. I appreciate it.
All righty. Well, everybody, until next time, don't forget to subscribe, like, and follow us. We would love that. So we'll catch you later.
Very cool.